Welcome back. This is some problem set practice using the wave speed law. So if you remember from previous class, you had the wavelength, which is lambda, okay, is times the frequency is going to be equal to the speed. Okay, so the speed of light, or the speed of sound, or the speed of any type of energy wave that you can think of. Okay, so they're going to ask you a couple questions. You have to remember that wavelength, or lambda, is going to usually be in meters. Frequency is in cycles per second. Okay, so cycles per second is just in divided by seconds. There's nothing over that. It's just nothing over seconds, which doesn't make any sense except when you have, for instance, wavelength is going to be in lambda. So lambda, which is meters, times divided by seconds, is meters per second. And meters per second is what your speed is. So that makes sense. Meters times seconds to the -1, or seconds on the bottom, equals meters divided by seconds. So that's what we're going to see. First question is, while flying to Tucson, Connie's plane experiences turbulence that causes the coffee in her cup to oscillate back and forth 4 times per second. So we recognize, first of all, that this 4 times per second is 4 hertz. And a hertz is 4, okay, per second. Just the number 4 over the units of seconds. Okay, that's its oscillation, or that's its frequency. Okay, we're going to ask what is the speed. So they're going to ask for velocity here, but they say that the wavelength, or the distances between the peaks in the ripples in her cup, is 0.1 meters. Okay, so 0.1 meters is going to be her. That's the wavelength, so this is lambda. So when you put this together, you're going to have, so they're asking for the speed, right? So the speed is going to be velocity, so V equals lambda F. So the speed we don't know, lambda we know as 0.1 meters, and the hertz, or 4 times per second, is going to be 4 over seconds, or 4 times seconds to the -1, and that will give you 0.4, okay, meters per second, or 0.4 meters per second, and that's your answer to the first one. Okay. Second problem, at a country music festival in New Hampshire, the Oak Ridge Boys, I don't know if you know the Oak Ridge Boys, they're old country singers, are playing at the end of a crowded 184-meter field. Okay, so I'll draw myself a picture. They're over here, and this is 184 meters across. I guess people are all here. Okay. It says, when Johnny Fairchild, I guess he's in the Oak Ridge Boys, hits a note on the keyboard with a frequency of 400 hertz. Okay, so that's a frequency of sound. So that's an energy, or frequency, of how fast it's vibrating. And the question is, how many full wavelengths are there between the stage and the last row of that crowd? So a 400 hertz is going to have a certain wavelength called lambda, and then the whole thing is 184, and they're asking how many full wavelengths are there as it crosses the field. Okay, so what are we going to do? We first have to realize that they're asking for lambda, so I have V equals F lambda. We already know that. We're going to solve for lambda. So lambda is the wavelength, equals velocity over frequency. Well, I think they expect you to know one thing. I'll always tell you, I'm never going to have you memorize this, but we'll learn the speed of light and we'll learn the speed of sound. This is sound. So speed of sound is 340 meters per second. That's how fast sound travels in air. Okay, 340 meters per second. The frequency is hertz. Okay, so the frequency is 400, okay, seconds to the -1. Or so what's going to happen is these two guys are going to cancel, and 300 divided by, or 300 divided by 400 is, or 340 divided by 400 is 0.85 meters. Okay, 0.85 meters is one wavelength. Okay, so now how many of those wavelengths is going to cross the entire field? So you'll have to take the whole field, which is 184 meters, and divide in what a wavelength is. Meters will cancel, and you get 184 divided by 0.85 is 216 full wavelengths, okay, full lambdas. Second question, how much delay is there between the time the note is played and the time it's heard in the last row? All right, so this is believe it or not, this is an elementary problem. You have rate, how fast something's going, times the time it travels is the distance it travels. Rate times time equals distance, okay? Or speed, rate we'll call speed, okay? Times time equals distance. Well, the distance we know is 184. The speed we know is 340, this is meters per second. So I need to solve for t. So I have 184 divided by 340, and when you take 184 divided by 340, you get the time equals 0.541 seconds. So it takes a half a second for it to cross the whole field before it gets to the last row. A lot of times you'll hear that if you have a reverb to where you're hearing sounds echoing back at you. Some sounds coming from a person's mouth, others coming from a speaker, which has a delay. And then if you're far away, you even have a third delay, and you can get kind of a muddy sound where doesn't even sound right. So I hope that's easy for you to understand. I hope you're learning something, and see you in the funny papers.